x-intercept, the y. So from here on out, if I take my parabola and I set it equal to 0, I'm going to solve that, and that's going to give me the x-intercepts. So before we get into the actual notes, I've got up on the board a little table, and I will write that right here. And we're going to do a little quick math. If you know your multiplication tables, this lesson will be much easier. Do you all remember factoring in Algebra 1?
No.
No. Okay. So I want you to come up with two numbers that, like in this first example, those two numbers, I can add them and I get 5. I multiply them and I get 6. What are those two numbers? 3 and 2. What about add to be 9, multiply to be 14? 7 and 2. Good. What about add to be 4, multiply to be negative 5? Negative 1 and positive 5. Good. Add to negative 6, multiply to be negative 16. Close. Negative 8 and positive 2. And then last one, add to be negative 12, multiply to be 27. Do what? Negative 3 and negative 9. So that's kind of, you're going to be doing a lot of that with factoring. So if you know your multiplication tables, you can get some of those without having to just type a bunch of numbers in your calculator over and over. So it'll be easier. So let's look at some examples, and the ones we do today are going to be the easier ones because my a value is 1. There's really not a number in front of the x squared, so my a is considered 1. And so I'm going to do something called factoring, which you should have learned in Algebra 1. COVID probably messed that up a little bit for some of you all. So I'm going to show you, but it's really, really simple. So I've got this quadratic, and it's set equal to 0. So I know that my y value is 0. And I can't subtract 21 and solve it that way because of the squared. The only way, or the best way to solve it, is with factoring. And so what we do is we look at my b value and my c. And I want two numbers that add to be negative 10 and multiply to be 21. What are those two numbers? Negative 3 and negative 7. That is correct. Because negative 3 plus negative 7. Yep. Negative 3 times negative 7. Yep. And so those numbers come down and become my factors. I have x minus 3 and x minus 7. And that's basically what you would have done in Algebra 1. So I've got two factors that I'm multiplying together, and I want them to equal 0. What does one of those two numbers have to be? If you multiply to be 0, one of them has to be 0. So now you're going to take each factor and set it equal to 0 separately. Because if I plug in a number that makes at least one of them 0, then the whole thing would be 0. So if I have x minus 3 equals 0, what do I do to solve? Add 3. And x equals 3. So I have a 1 x-intercept at 3. And this one I would add 7 to get x equals 7. You're going to be tempted to get these two numbers and just assume that your x-intercepts are going to be the opposites. So you're going to be like, well, -3 and -7, so my x-intercepts are +3, +7. That is only the case when we don't have a number in front of the x squared. So that's not a good habit to get into, because when we get to the harder ones tomorrow, then you'll mess up. Okay. So always, even if you know that it's going to be 3 and 7, go ahead and write this out. Okay. So let's look at number 2. We need two numbers that add to be 8 and multiply to be 15. 3 and 5. And it doesn't matter if you put the 3 or the 5 first. So we have 3 and 5. So those numbers I put in my factors. X plus 3, x plus 5. And really what we're doing here is we're kind of undoing the FOIL method. If I have x plus 3 times x plus 5, we've talked about FOIL a little bit. That was some Algebra 1 stuff, but we've done it with ACT. Essentially, I'm doing x times x is x squared, x times 5 is 5x, 3 times x is 3x, and 3 times 5 is 15, and that makes 8x there. So really, when I factor, I am undoing, or I'm doing the opposite of FOIL. Okay, so that's why we can write it both ways. So I'm going to set that factor equal to 0. And I get x equals -3. And x equals -5. If I went to my y equals and typed that in, I could look at the graph, or I could look at the table and see that I have an x-intercept at -5 and an x-intercept at -3.
How do you use the table again?
Second, so you've got to go to y equals and type in your equation, and then you see above graph where it says table in blue?
Yes.
Yeah, so you would hit second and then you hit graph to go to the table.
And in that calculator, x doesn't mean anything.
Right, whatever you have stored as x doesn't matter, like when you're doing your y equals and that kind of thing. Number 3, what's the problem with this one? It's not equal to 0. it has to be equal to 0 before we can solve. So what would I do to get it equal to 0? Subtract 80 from both sides. Do I have any whole numbers on the left side? No. So it's just going to be separate. X squared plus 2x minus 80 equals 0. So I need two numbers that add to be 2 and multiply to be negative 80. What are those two numbers? 10 and negative 8. So my factors are x plus 10 and x minus 8. X plus 10 equals 0 and x minus 8 equals 0. And one x-intercept at positive 8. If you wanted to type this in on your y equals to check it, you have to type in the version that's set equal to 0. You can't type in the original. So anytime you type one into your y equals, it has to be set equal to 0 first.
When you're putting it in the calculator, do you have to set it to 0?
No. It'll be like y equals, and then you just type in that. Number 4 is not set equal to 0, so I need to subtract x, and I need to subtract 4. And that gives me x squared plus 10x plus 25 equals 0. So what are my two numbers? 5 and 5, yep. Since these are identical factors, we will get the same number when we solve them. So this means it actually only has one x-intercept. You don't have to write it twice. You can just do one of the x plus 5 equals 0. Sometimes you may see this wrote as x plus 5 squared equals 0. Because when you multiply something by itself, it's the same thing as squaring it. Are there any questions on this?